Hi folks, we're beginning to learn about Newton's laws of motion this week. This is just a short video that's going to explain Newton's first law. You can see that there's 3 in total, so we're going to start off by looking at the first law of motion. Newton's first law says that an object will remain at rest or move at a constant speed in a straight line unless acted upon by an unbalanced force. Now that seems a lot of information and it seems complicated, but we can break it down and make it simpler. Basically what it tells us is what happens when forces are balanced. If the forces on an object are balanced, an object that is at rest will stay at rest. If an object's already moving and the forces are balanced, it will keep moving with the same speed and keep moving in the same direction, and that will not change so long as the forces are balanced. If the forces change and become unbalanced, that's when this motion will be different. So you won't have an object remaining at rest, you won't have an object continuing to move at a constant speed in the same direction. Unbalanced forces will change that. Here we can explain how an object stays at rest and how an object continues to move at a constant speed by looking at the forces acting on the object. So on the left, you can see the apple's at rest. It has a constant speed of 0 meters per second. It's not moving. The reason for that is because the forces on the object, on the apple, are balanced. We learned about balanced forces last week. Balanced forces are equal in size and opposite in direction, like you can see from the picture, which means the 3 newtons to the left will effectively cancel out the 3 newtons to the right. This will give you no resultant force, or you could say the resultant force is just 0 and the apple is at rest. It's staying stationary. It's a little bit more difficult to understand how balanced forces can make something continue to move with the same speed. So the apple on the right is falling with a constant speed of 2 meters per second, and the reason for that is because the forces on that apple are also balanced. But you might be wondering how an object can keep moving at the same speed if it's got balanced forces, if the forces should be cancelling each other out. So I'll show you another example to try and explain that. So you can see here, the definition for Newton's first law is an object will remain at rest or move at a constant speed in a straight line unless acted upon by an unbalanced force. And you can see I've tried to break that up a little bit into 3 kind of main parts. So basically, if forces are balanced, your 2 options are that your object will stay at rest or your object will move at a constant speed in a straight line. Those are the 2 things that could happen when the forces on an object are balanced. If they are unbalanced, if they become unbalanced, then the object won't remain at rest, or if it's already moving, it won't continue to travel at a constant speed in a straight line. So basically Newton's first law tells us the 2 possible options when forces are balanced. That's either at rest or travelling at a constant speed in a straight line. As soon as the forces become unbalanced, these things no longer happen. Now you can see the image of the cyclist here on the screen. At the moment, the cyclist is at rest because all the forces acting on the cyclist and the bike are balanced. When the cyclist begins to pedal, that will obviously change because the bike will start to move. When the cyclist pedals, you will see the force acting to the right would gradually increase. The cyclist wouldn't remain at rest anymore they would begin to move. That would obviously be a case where the forces are unbalanced, because the pedal force would be greater than all the frictional forces acting in the opposite direction to the left. Now, as the cyclist pedals, they will start moving to the right. And at the beginning, the pedal force will be quite a large force in order to get the cyclist going. It will be much greater than any frictional forces acting to the left, trying to slow the cyclist down. At the beginning, that will be the case when they start pedalling. But any example that you can think of where an object increases its speed, what you'll know is that the force to make the object move forward will be large to begin with. But the faster you go, what will happen is that the frictional forces acting in the opposite direction, they will gradually increase as your speed increases. And basically what happens is the speed of the cyclist will increase at the beginning. As soon as they start to pedal, the pedal force will increase, and that will increase the speed of the cyclist. But the more the speed increases, the more this frictional force, these frictional forces acting to the left, they will gradually increase as well. And what will happen is there will come a point where the cyclist has reached the maximum amount of pedal force that they're capable of. And at this point, all the frictional forces acting in the opposite direction, they will increase and keep increasing as long as the speed of the cyclist is increasing. When the cyclist reaches maximum pedal force, the friction force will reach a maximum as well, and the two forces will be balanced. And that means that the cyclist will now travel at a constant speed in a straight line. They'll reach a point where they can't go any faster, and that's because the forces are now balanced. So Newton's first law tells us an object will remain at rest or move at a constant speed in a straight line unless acted upon by an unbalanced force.